And we are live, and welcome to Climate Chat. I'm your host, Dan Miller, and today we have a very special guest, Professor Stephen True, who has a lot of things in his background, and I think I'll just summarize very high level. Worked at Bell Labs, won a Nobel Prize in physics for cooling atoms. Also, that work, I believe you were at Stanford also during doing that work.
Mm-hmm.
And then went on to be the head of the Lawrence Berkeley National Laboratories, actually where I first met you. Then was U.S. Secretary of Energy under President Obama, and is now back at Stanford doing lots of interesting things. And in order to start off here, before we start talking about climate-related things, although maybe some of this is climate-related, I'd like to hear about some of your current research at Stanford, because this is something that I think most people don't know about you.
Well, it's eclectic. When I left the Department of Energy, come back to Stanford, I wanted to do new things, things I hadn't done before. And so all the things I'm doing now are things I did not do before I left to join the Department of Energy. One of the things is very fundamental biology, looking at how cargoes move around in neurons. Doing this by introducing new technologies with new technology, you can see things in live cells you couldn't see before. And so when we did that, we discovered that this very important motor called dynein doesn't work the way people thought, which means that it delays publication for 3 or 4 years as you mount more evidence to overcome the skepticism. We may be wrong, but I think we're right. But now we're developing a technology that can actually see in live cells movements of cargo vesicles with 1 microsecond resolution and 0.12 nanometers, about the size of an atom in the live cell. We're doing other things. Nonlinear ultrasound imaging. We think that different kind of contrast. You see tumors you couldn't see before. Working on batteries, trying to cut a different path in batteries. Especially excited about the prospect of utility scale batteries in water solutions, aqueous solutions, and trying to overcome the idea that if you have a water-based battery, which is a lot safer than the current lithium-ion technology, you're limited by the voltage that will split water, about 1.3, 1.4 volts. If you can get that higher, 3 or 4 volts, you can have a comparable energy density to the best lithium-ion batteries. So it's a radical approach. Don't know if it's going to work. And finally, we stumbled on a method of capturing carbon, which could be by 3 or 4. There are other methods also that people are looking at. So it varies all over the map. I think we're going to need any good method that dramatically lowers the cost of capturing carbon, either from point sources, steel, cement, plastics, power, but also from the atmosphere. And there's a possibility that this could actually get air captured carbon dioxide below $100 a ton. But that's a wild guess. But it has attracted a lot of attention among people who twisted my arm to finance this startup company.
Wow.
I was a reluctant. I said, no, it could go wrong. This could happen. This could happen. I said, no, we have faith. So anyway, that's
quite a eclectic group of technologies there.
It's essentially one graduate student or postdoc per project. And so it's not like I have a huge army. I just like to bounce around. And it's actually good for the group that they can see very widely different areas in science and technology.
So we'll probably get back to the carbon capture thing briefly in a little bit. But I want to start off with what your view of climate change, before we talk about politics and maybe tech solutions, just sort of like, where do you see us at now in terms of the current warming and where you think we're going to be in, let's say, 10, 25, 75 years from now? Like the path where we're at and the path we're on.
Well, this is going to sound a little odd, but we don't really know where we're at. And the reason we don't is it's a very simple explanation. If you consider you have additional greenhouse gases, and so that traps additional heat. This additional heat, the sun varies with the solar cycle, but over several solar cycles, it's pretty constant. But the additional greenhouse gases are trapping more heat. 90% of that heat is going into the deep oceans.
Right.
And so as long as the deep oceans think of this big ice cube. And so what determines the weather is the surface temperature of land and ocean. But then you've got this big heat sink. And so the damage we've already done, more heat trapping, is actually being hidden by warming up the oceans. We don't know the exact time scale, but 50, maybe 100 years before we know the real damage of what we've done today. And so this is something that's easy to explain, but I think most people don't fully understand that. They see in the last 10, 20 years, the weather's getting weirder. Certainly in the last 5 or 10 years, you see significant rainfalls, temperatures, things like that. But the scary thing is, it's like smoking cigarettes for 30 years and not knowing you've built up a series of mutations, and the price won't be paid maybe for another 20 or 30 years. And so this is something that's deeply concerning. Now, having said that, the world was going, but it doesn't realize the urgency, because most of the effects are 50, 80, 100 years, 200 years from now. But again, it's like the Titanic. When you spot an iceberg ahead and the guys in the crow's nest say, turn, why aren't you turning? And the reason is it takes about 75 years to turn this ship, roughly. And so the time scale, even if you do hard right rudder now, it's going to be 60 years minimum to get rid of all the carbon emissions from hard to abate sectors, especially agriculture and the materials that we still depend on. And so it's not just a matter of electrifying power or automobiles. And what people don't realize is around the world, carbon emissions, greenhouse gas emissions, about 20, maybe as much as 25%, if you include food waste, is due to agriculture. And that is really hard to abate because we use fertilizer. And fertilizer not absorbed by a plant becomes N2O emissions, which is 300 times worse greenhouse gas than carbon dioxide, and it lasts 100 years. So it's a really bad actor. I can see us getting rid of lots of carbon. We can get rid of a lot of methane, but fertilizer in a world of 8 billion going to 10 or 11 billion is harder, much harder. And so that's another thing I'm doing. Actually another research project. I think the solution could be biological. If you can alter microbes that live on the edge of plant roots, crop roots, and the rhizome, you can actually get these microbes to fertilize the plants. It's been inspired by legumes and things like that, soybeans. There was a partial success with corn, but it only limited half to fertilizer, but it took too long to develop, maybe 8 years, 9 years, and the soils are different. And I was on the board of a company doing this, and it went bankrupt because of that. So I realized if you can increase the development time, if you can do it in a couple of years, then you can begin to do this with all the major grains. It will actually help productivity, I think. It will help developing country farmers because fertilizer is pretty expensive. And so it's something that is well worth taking on. The world over the last decade, maybe half a decade, has woken up to the fact you've got to address agriculture.
Sure. Now, in another interview, you said you thought you saw us going to 3 degrees. Not something that most people talk about, they give the hope of staying under 2, depending, and sometimes they're described as smoking hopium or something like that. But what's your feeling? We're headed past 3 degrees this century, and that would be catastrophic?
Well,
or what's your thoughts on that?
right now, we're not on track to follow the UN pledges.
Right.
And the UN pledges, actually, if you have to believe in the climate models, there's large uncertainties in that. So with that caveat, uncertainties both ways. But if with that caveat, we're heading towards over 3 degrees. Don't really know what's going to happen if we go to 3 degrees since the beginning of the Industrial Revolution.
Right.
We're about 1.5 now.
Right.
So we don't really know what's going to happen. One thing that we're beginning to learn is that the climate system of the Earth is probably more sensitive than we thought. But this is, again, early data. But I think 3.5 degrees, and that will be bad news. There's already lots of political, social instability in the world, exacerbated, not caused, but exacerbated by climate change. And so that's one of the things I worry about as well.
So I'd like to go through quickly, like a lightning round kind of thing. You kind of started touching on these things. These are sort of solutions for climate, and just what you think of them and how realistic they are, useful, whatever. And that is the first one would be 100% renewable energy by, let's say, 2050 time frame or thereabouts. Do you think we could do that? More than just electricity,
I don't think so. And it also depends on where you live. If you look at Iceland and Norway, they're already that because they have huge hydropower. If you live in a place like Singapore, there's no land. You can't have solar. You can't have wind. It's a little place. Taiwan, very mountainous. They have very little onshore wind that's any good. And so what do? Right now, they get most of their energy from fossil fuel, coal and natural gas. I actually am trying to encourage them for their own energy security to re-embrace nuclear power. The reason is if you blockade Taiwan, you've got about 10 days worth of natural gas and it's all over. And so nuclear power can be introduced safely, I believe. And I think for energy security reasons, in places like Taiwan and other places around the world, US, we can be 80% renewable. We only need roughly 3 days of energy source to be 80%. Can we be 100%? Well, there are instances when the wind stopped blowing for a week, maybe 2. The record is 2 weeks. So wind, solar, you can, if you want to keep the lights on, keep industries going, you need backup power. And so that backup power is going to either be in the future, natural gas or nuclear. Now, you can debate whether it's 20%, 10%, 15%. I don't care. You still need some backup power unless you're willing to turn the lights out.
Okay.
And curtail energy.
So you hit nuclear. So we'll go to the next one. What do you think of the hydrogen economy? A lot of hype about that, but
possible. But right now it's very expensive. Too expensive. We get our hydrogen now from steam reforming methane gas, and we vent the CO2. Now you capture the CO2, it adds to the cost, maybe 1.5, maybe double. Because the United States is very rich in natural gas, we have some of the, aside from the Middle East, we have some of the cheapest natural gas around the world. Hydrogen can cost $1.50 a kilogram. At
that's not green though. So
no, that's not green. You go green, you're $2. If you go really green and stay away from using methane as a source, because you have methane leaks when you explore for methane and it leaks out, and then you've got to capture the carbon dioxide, and you're not going to capture more than about 95% of the carbon dioxide in the shift process of converting methane to hydrogen. And so these all add. So the best solution is you have very green electricity, non-carbon emitting electricity, and convert to hydrogen. But right now it's very expensive.
And what your thoughts on the fact that hydrogen is a very powerful indirect greenhouse gas and it's the leakiest molecule in the universe? Any thoughts on that?
That is a problem, a very big problem. And we cannot have hydrogen pipelines until we have a method of detecting hydrogen. But therein lies another problem. There is no spectroscopic signature of hydrogen. Now,
Wow.
it's a symmetric molecule. When we have optical detection of methane, we found that the methane leaks were more than originally thought.
Of course.
And so without a method of detecting hydrogen, and because it can be effectively a potent greenhouse gas, you need to detect hydrogen. There are two ways of doing it. One is mass spec. You actually, in a vacuum, you ionize it. Since there's so little helium around, it's a very clear signature. And the question is, can you make a mass spectrometer the size of a fist, put it on a drone, and the drone can go up and down pipelines? Now, that would work. You're not going to be able to detect mass spec from satellites. Or a chemical means where hydrogen absorbs on something, it gives a signature, and you desorb it and replenish. So there are technologies that could be available. Drone technology is advancing very rapidly. But in lieu of that, if you have a hydrogen economy, you actually have to use it where you make it, because transporting it right now is in compressed tanks. So it's not economical. But it really depends on how the whole system has to be taken into account. Having said that, it could be used as a source of heat, but a reducing agent for steel. There are it's right now, its primary application is to upgrade petroleum to higher value products. But it could find its way into a lot of other things in the chemical industry, the steel industry, things like that, which of all those industries, we also have to decarbonize, both the heat and the chemical reduction process.
Right. So instead of using it, as an energy storage, which is maybe possible, but in industrial applications like it is used today, and replace the fossil-based hydrogen, that would be good. So let's get to you. One, you touched on carbon dioxide removal or carbon capture. Do you think that's an essential technology for maintaining a safe climate?
I think it is. Not everybody agrees to that. But some people feel, if you have carbon capture, it gives a license to the fossil fuel industry and all the big carbon emitters to continue as business as usual. I feel differently about that. I think, given that it takes a long time, decades, to throttle down and throttle off the carbon emission from all our industrial processes, as well as power, as well as transportation. I'm not talking about EVs. I'm talking about heavy-duty trucking, airplanes. You need something to get the carbon out of the atmosphere and out of all point sources. And so I think it is very necessary that we need this, not to keep the fossil fuel power generation industry alive, but until we decarbonize all the other sectors, we will need something. We emit 40 gigatons of carbon dioxide a year. If you include methane, N2O, and other greenhouse gases, could be 50. So realistic, we're not talking about megatons. We're not even talking about 1 gigaton. We're talking about tens of gigatons.
Correct.
And that is enormous. All of landfill is 2 gigatons. And so if you're talking 10 gigatons of much lower density stuff, it gives you a sense of the volumes that you have to store. And not surprisingly, the volumes you have to store are comparable to the volumes we've been digging out of the ground in fossil fuel.
Of course. Okay, so now let's get to a little more controversial than that. What's your thoughts on the need for solar geoengineering, also called sunlight reflection methods or solar radiation management?
When I was in Secretary of Energy, we thought, well, that's pretty extreme. We don't know the unintended consequences, and so it would be an act of desperation. That was in 2009, 2010. Now, in 2025, I said, We probably will need it. Now, the good news about this, and we're now specifically talking about small particulate matter in the upper
Yeah,
atmosphere.
stratospheric aerosol injection.
Right, right. And there are Hadley currents that will keep the particles up there for about a year, year and a half, and they come down. The first proposed particle, sulfur dioxide, had unintended consequences. It acidifies the ocean. It does other things, and possibly could damage the ozone layer. So we need something else that's very inexpensive and chemically inert. So when it does come down, it's not going to do something terrible to the ocean. It's hard to say, so you don't do this. You maybe do experiments and try to find out, what are the unintended consequences before you do large scale stuff. But the best geoengineering, I think, is not aerosols in the atmosphere, but attending to agriculture, because the arable land, and we're using half the arable land in the world for agriculture. So in a sense, agriculture has geoengineered the world already. And so if you can figure out how to emit less greenhouse gases for better farming practices, and again, trying to get rid of the N2O emissions, the methane emissions also from agriculture are significant. So I think you start with something we've already engineered while doing careful experiments to see, is it possible? And what are the unintended consequences of geoengineering in the atmosphere? The oceans, I would leave alone. It's too risky. Whereas agricultural land, very, very different.
Okay. So I want to move into the political realm, but before getting specific about your time in the Obama administration, in general, we've known about the climate problem, since 1896, but specifically, Jim Hansen warned Congress in 1988. So since the 1980s and even before, but we've known it's a serious problem. Yet globally, and not just the United States, but globally, very little action to address it. Do you have any thoughts on sort of the bigger picture? We'll get into the Obama administration soon, but why it's such a difficult problem for political leaders to take on?
I would say first, in the late 1990s, early 2000, mid 1990s, I wasn't really convinced how certain it was, but now it is. And in the last decade, I think the evidence is overwhelming. It's real. It's primarily caused by human fossil emissions, and the seriousness of this can't really be doubted by people who've really studied and thought about this. But to answer your question, energy makes the world go round. It is the cause over the last couple hundred years of enormous prosperity for the world in the developed world, and in the developing world is a necessary ingredient to raise prosperity. So it's incredibly important. The question is, can you make a transition? Because coal is abundant and very inexpensive. Natural gas is not as abundant, but there's a lot of it. We've only recently brought in prospect for natural gas. It was a byproduct of oil production. But the reason it's so hard is because the cost of energy goes to the cost of many, many things, and lies at the heart of industrialization. And so you need to make this transition in a way that doesn't stilt the growing prosperity of developing countries. I think developed countries have the wherewithal; they can make this transition, but you've got to be able to do it in the most efficient way. So again, because the economy will, if you look at the rank order of things, and the Russian invasion of Ukraine show that energy security trumps climate change.
Well, in the short run.
And the climate and the economy if it really has a downturn, will trump climate change as well. So one has to do this in a way that keeps the economy strong,
Okay.
the world economy.
So let's shift into the Obama administration, where you served as energy secretary.
Mhm.
I heard in another interview you said that before you, I think even before you took the job, that President Obama said that climate change was one of his top two priorities, and he certainly spoke eloquently about it. And while you were Secretary of Energy, there were a lot of innovation, ARPA-E, and other programs to help improve energy efficiency and things like that. Yet overall, the Obama administration had an all of the above energy policy, which meant not just we're going to do the clean stuff, but we're going to even do more fossil fuels. And this was not like a mistake or something. This was the central role, and quite proud of it. I think President Obama was proud of that. Yet when you're fighting climate change, one of the rules are you have to actually reduce fossil fuel emissions. I mean, you just really can't get around the central need to do that. So why? So, and I'm confused about that. Can you explain like the difference between the rhetoric of President Obama, and again, climate change, a critical problem of our time, et cetera, yet supporting the expansion of fossil fuel extraction in the United States?
Well, again, it's the economic pressures. I think he was absolutely sincere and tried very hard. And as you noted, that was one of his two top priorities: reform healthcare in the United States and do something about climate change.
Mhm.
And during the time I worked with him and for him, I guess we were both working for the United States. I think he was unwavering in that. But the realities are you've got to get bills through in Congress. There's only so much you can do with executive orders, and with executive orders, the next president can reverse them. So it's like Lincoln trying to get the the amendment that abolishes slavery. Presidential order, Emancipation Proclamation doesn't do it. You've got to actually get it written into the laws of the U.S.
But there was a big push for put a price on carbon. Now you can argue whether that was the best way to price carbon, but the Waxman-Markey bill was a true carbon tax, cap and trade, so not the best, but still. And yet, I think at the time, President Obama did not go out to Congress and push to get that done. He didn't put all his weight behind trying to get that passed. So, any thoughts on that or why that was?
I don't really know. I think, one can always say you could have pushed harder. It's always true. But if one pushes too hard, you fall on your sword. But I'm not going to want to make excuses for the president. I think he also had to face the other side of political realism. But had I hoped he would push harder? Sure. But we are where we are, and we're where we were. Right now, going in very much the opposite direction.
That was my next question, actually. So we're in a very, very different world now. We have an administration that actually thinks climate change is a hoax. And as I guess they accepted campaign support from the fossil fuel industry and promised to do good things for them, which they're certainly doing. So pushing fossil fuels as much as possible, dismantling climate, not only climate programs, but climate science. And just want to get your overall thoughts or reactions to the current situation of the dismantling of climate action and climate science in the United States.
Well, it's part of the dismantling of many, many things. There's a large fraction of the United States, bordering on half, which is beginning to mistrust science, beginning to mistrust universities, other things. And the other thing is, there seems to be an alternate set of facts that if you say them often enough, loud enough, maybe there's going to be some reality to that. If you compare that to Europe, China, China, a large fraction of their government are surprisingly are engineers, some with PhDs in engineering. And in a government like that, you're not debating the reality of climate change. What's the major cause of it? It's what do you do about it? In the United States, we're still, debating: is it real? Is it really caused by humans? And with some significant part of the population not sure. Industries that are incumbent industries that depend on fossil fuel do try to muddy the waters. Now it's so again, it's a bit of a mess. There's a deeper thing in this mistrust of science,
Right.
or you can have alternate science or alternate facts that where there is no data, but you just state X, Y, and Z. And so so if it's no longer a serious discussion, if it's among serious people, you say, let's agree on the data, what's trustworthy, what's not trustworthy, get together and start from there. If you can't start from that, there's an issue. And this is, science, sometimes it takes years, decades, even longer to actually fully understand what's going on. But the process of continuously reevaluating, trying to get more information, more data, and thinking deeply about it is something that has steered the development of the world for hundreds of years. And so to have that questioned is very sad.
Right. And so it actually goes beyond just climate science. They're cutting back on cancer research, everything. And this is going to what's your thoughts on the competitiveness of the United States with losing some of its best scientists and funding for young scientists to become the great scientists of the future? I mean, it's a little bit beyond just climate in this case.
Oh, absolutely. I think if you look back in the history of the United States, we had gifts. Without immigrants and immigrant scientists and immigrant students, we would not be where we are. This started in the late 20s, early 30s, with the rise of Nazism and fascism in Italy, the Communist Revolution in 49. These things, we had these great gifts. And we're now taking it for granted. Not only not taking it for granted, we're actually trying to close the door on immigrants who have added much to the scientific prowess and the technological prowess, and hence the wealth generation in the United States. For example, about a third of the Nobel laureates who were listed as, quote, American when they got the Nobel Prize were first generation immigrants. If you include second generation immigrants like me, my parents during World War II went to MIT to go to graduate school. And then after the Communist Revolution, they couldn't go back in 49. So they raised their family. And all the people in China on both sides of the family who had PhDs, were professors, had to leave. They would be killed. Now, so that's one example of how immigrants have really added to the science in the United States. Now, to say that we don't want this anymore, that we want to turn it off, is really crazy. The many foreign students come to the United States. The United States is an amazing country. You can be first generation and certainly second generation. You become American. I don't really think when people interact with me, they don't think, okay, first you're Chinese. No, they think I'm an American. And that's not true in Europe. You can be second and third generation, and you're still a foreigner. And so the wonderful thing about the people in the United States is they will accept you because we are a country of immigrants. Now to want to turn that off and to turn off this welcoming mat. And most of these young people, students, especially graduate students, postdocs, they come here, they stay here, they raise their families here. They become US citizens. If you look at all the Nobel laureates who were from China or Turing Award, Fields Medal winner, every one of them, as first generation, became a US citizen. So it's, it tells you something about it. Why do you want to stop this?
That's right. So let's look past this current administration, and let's assume that, I guess, there's enough climate shocks that people actually want actual real climate action. Maybe you run for president and as your president. What do you think we should do to, I guess, two things. One, to get the public engaged on the issue, because they're very distracted now and not really focused, even though they can see it happening all around them. And secondly, to do something that we failed at in the past, to get political leaders to take serious action to fight climate change. What would be your recommendations for how to accomplish those two things?
Well, first, I want to step back and generalize just from climate change. I mentioned before there were 8 billion people. The predictions by mid-century maybe go to 10. Certainly by end of century, 10 or 11 billion are the predictions. There's a natural tendency when people get wealthier to have smaller families. But this is not, you don't have to be really wealthy or even middle class. If you look at the fertility rate in European countries, in Asia and Korea, Japan, it's actually 2.1, 2.05 is the break even. Children per woman. The fertility rate in Korea is less than 1. Japan, 1. And so there's a natural tendency to have smaller kids. And I've been encouraging people, why are you encouraging people, it's to have bigger families, to maintain or increase the population. It's a Ponzi scheme. Right. If you have more new investors investing, you don't actually have to be profitable and you can pay off the old investors. So the idea is that you want the population of the world to naturally decline. Now, where will it end up? I don't know. I mean, there are projections that could go, right now we're 8 going to 10 or 11. Could it go to 1, 2, 3, or 4? Maybe.
I mean, naturally, not through climate disaster, but
just naturally. Now, what about prosperity? Well, the economists say, no, you need at least the same number in the workforce, but there's something else. We have automation. If you think about mechanized farming, you replace the farmers. So the farmers, you didn't need as many farmers to raise more food. But there were new jobs because of industrialization. So they go to the cities and build stuff, whether it's cars or washing machines or whatever. But now there's automation, and if you're in manufacturing and you don't automate, you're going to be gobbled up by your competitors who do automate. And so the need for factory workers is also going down. Now, so just play this out. Let's figure out how to use increasing automation, eventually robots, inexpensive robots, to start replacing all the dirty and disgusting jobs that we have minimum wage people do. You can maintain prosperity and let the population decline. And so there's virtually no one I see in government talking about these things. I don't know why.
Third rail. Well, population is third rail kind of thing, right?
Well, no. This is not enforce anything. This is just let something naturally occur. And if you want to really talk about sustainability, how can you say it's okay to go from 8 to 10 billion and consume more and more and more? So that there are other things. The worship of GDP is actually, in some aspects, contrary to that, because it encourages growth, but it also encourages use once, throw away. You can increase the GDP by building buildings that last 50 years, not 500 years, tear them down and build another building. You can increase GDP by not making cars last 30 years, but let's say 15 or 20, washing machines, refrigerators, all these consumable things. So there's forces that work here that are also contrary to what you want to go towards using less of the Earth's resources. And so these are things I think that should be part of the discussion today in any well-to-do economy. I separate that from developing countries where GDP does really mean a rise in living standard, things like that. Whereas in the United States, among the richer half, or 2/3 or 1/3, you can draw any line. There are other things that matter, and does one really need 2 homes or 1 car per adult, or these other things? I'm not sure, but so these are some of the forces that work here.
Okay.
But politicians, this goes to productivity, this goes to a lot of things, so it becomes a little dicey of how one talks about it. But these are the overall issues, I think, in the long term.
And one of the big issues in government is the power of fossil fuel industry in politics, in all phases of it. Is there anything? Do you see anything changing in that over time as climate change gets worse, as renewables become a significant part of our energy supply, where the political power that's preventing action on climate from fossil fuel industry might change in the next decade or so? I mean, obviously not this administration, but
not
beyond.
this administration. I don't know. I think the fossil fuel, the oil and gas industry, I think they know what's at stake. But they, if you're a CEO of an oil and gas company, or the chair of the board, the first duty will be to your shareholders. And it's very rare that an incumbent successful industry will work to phase themselves out. Now, there was a time where progressive oil and gas companies, especially in Europe, Royal Dutch Shell, BP, or 2 examples, they were making investments, significant investments. I'm not talking about 5%. I'm talking about 50% or more than 50% of the investments in shifting from fossil fuel to greener energy, wind, things like that.
Right.
And what happened was that the Wall Street analysts, among others, said, you're not going to make as much money as ExxonMobil and Shell if you do this. And so
so it's profit driven.
Literally backtrack, because again, if the shares of their stock go down, then what happens? And
beyond petroleum at one point.
This, this has happened, and it's quite sad.
So we're going to get to some other questions from others here in just a moment, but any overall thoughts on our climate predicament? And I don't know, when I'm looking back on the last 20 years or so giving talks on climate, the only thing I've seen that really has had impact on the public is climate damage being identified as such. Do you think that's going to be the path to get us to engage, is the fact that things are going to get so bad and we're going to notice it and not be able to deny it after a while? Or do you see other more thoughtful kinds of things working?
I think first, it's going to partially, it has to be a technological solution. I've been saying this since my time, even before Secretary of Energy, where I quoted Sheikh Yamani, who said, "The Stone Age did not end for lack of stones, and the oil age will not end for lack of oil." And what he really meant by that was that you transition to better solutions. You went from stones to metals. Hold on. Sorry about that.
Okay.
Let me turn off my phone. You transition to better solutions. And so what that means is when you go to metals, you don't look at the rocks on the ground and say, if it weren't for politicians, we wouldn't have these stranded assets. So I think part of it is you get better solutions. Better solutions also mean more economical solutions. There will come a time, excuse me, where EVs will cost without subsidy less than internal combustion engine cars, that they can charge in about the same amount of time, maybe not to go 400 miles, but 200 miles in 5 minutes is well within the realm of possibility within 5 years, 10 years max. That the operation of an EV, the maintenance costs are far less. And so it could be a better solution. And you've got to get a lot of refueling stations around all within. So that's an example. LEDs versus incandescent light bulbs. Okay, 20 years ago, way too expensive. Now they're a good deal. They last forever, and that's part of the problem with LEDs. The old joke is how many economists does it take to screw in an LED? It says it doesn't take any. It's the same one that grandma put in. So,
Right.
so there are technical solutions that are economical. We need more of those. That's not to say we need some political will to nudge the progress forward, but in the end, it's going to be a mixture.
Although so far 100% of renewables have gone to new energy supplies, since obviously fossil fuels are at a peak right now, which meant maybe we decreased how much they might have been, but they're not going down. And so even with these technological solutions, we have to figure out ways to actually phase out fossil fuels, not just have more stuff that's clean, I guess.
Yeah, I would say there was a time, a couple decades ago, where people, the age of peak oil, and I would say, no, there's not going to be peak oil. We had peak oil in the US because we transitioned to the wider globe, but the ability to find and extract oil and gas has been improving. It used to be you poke a hole in the ground, you get 5 or 10% out, then routinely you get 50% out. From 5 to 50%, that's tenfold more per reservoir. But you can also find it. You can go deep offshore. You can do other things. And so the ability to find and extract economically, and economically means $60 a barrel type economics, is improving. And and there's lots of oil and gas in the ground. And so again, your competitor is not staying still. And so the renewable energy, the alternative energies, have to go faster if they want to be better.
It's going back, like in China, by the way. They're deploying at some crazy rate. So that's some good news.
China's energy appetite is huge because this drives their economy forward. They're 1.4 billion, we're 350 million. They're twice as much carbon emissions, so on a per capita basis, and they're doing heavy manufacturing. So they're investing in fossil, but they are also the biggest investor in renewable energies, comparable to the rest of the world combined in renewable energies. So again, they're trying to move forward, and climate change is not up to debate in that country. They're trying to move their economy forward, but they also know that there are serious consequences of climate change.
Right. So we're going to go to some questions from our co-mods, and then also maybe some from the YouTube audience. I'm going to invite Stacy in. Hey, Stacy. Can you hear us okay?
Sorry, mute button.
Oh, there we go.
Yeah.
Welcome.
Hi, Dan. Hi, Stephen. Thanks for being here. This has been such an interesting conversation. You had me going, ooh, yay. And then, did he just say that? So I appreciate having my views challenged. I wanted to echo your sentiments on population degrowth and annoyance at consumption and planned obsolescence. I totally agree. That is like the little gremlin in the system here. I am curious, were you and Tom Vilsack friendly?
Yes. Why do you ask?
Because you were ag, even though you were the energy guy. And so I didn't know if you were frenemies or
No,
not.
no. We
Secretary of
surprisingly,
Agriculture.
I don't know about the second cabinet. I was there for 4 1/3 years, but the cabinet was very, very supportive of each other. There was a lot of hullabaloo when he first appointed the cabinet members. He actually
Mhm.
appointed people based on subject matter expertise rather than political payback. It's kind of unusual for a president. And then it was speculated, all these people, they're going to be like Lincoln, the team of rivals, they're going to be at each other's throats, and that did not happen.
Okay.
That's what you happen when you get bright people together in a room, I guess. So my original question is, if you could go back to the beginning of your time as our Secretary of Energy, would you change the substance or name of the all of the above energy policy?
Well, I would have hoped that it would more favor clean energy as much as feasible, given where the Congress was. But I think presidents in the United States have enormous influence, and the question is, what do you use it for, and how secure are you in using it? President Obama was a brilliant person. I wish he was a little bit bolder than he was, but if you think of his place in history as the first Black president, you can also say, well, if he pushed too hard, what's going to happen? But look, I wasn't president of the United States, so it's easy to criticize. So I don't really mean this as a criticism, rather than an observation of some realities. But
I agree. I just remember when, well, I don't remember personally, but I learned in history class about the first Catholic president we had. And I think he tried to push a couple buttons as well. And you were saying like the president can only do so much, but 2009 to 2011 was that golden period that I fear I will never see again in my lifetime, the way things are going. And I just lament what we might have been able to do on a number of fronts, and most importantly for our conversation about energy.
Your comment about comparing Obama to John Kennedy is a good one, in the sense that Kennedy, just raised a Brahmin. Okay, so he was from a different place, and he pushed very hard, but it wasn't a slam dunk that he was going to get reelected. And if you remember back in history, I was growing up there and saying, was he going to get reelected? Not sure. He was pushing very hard, so who knows what would have happened? Who knows what would have happened if Kennedy lived, if Lincoln had lived? I think the country would have been better off.
For sure.
So Stacey, we'll get back to you with maybe if you have any good YouTube questions. We're going to go to Eli and then to Leon. Okay. And Eli, welcome. What's your question for Steve?
Hi, thank you. So given that extremes are overtaking us earlier than expected, do you think that accelerating efforts at making carbon dioxide removal more economical and scalable into deep negative carbon fluxes to reduce the ultimate driver of climate disruption, and also accelerating research into solar radiation management in case we've underestimated climate sensitivity would be among the best strategies available? What would your plan be?
I don't think we should pin all our hopes, or a large majority of hopes, on carbon removal things like that, or geoengineering. I think you got to look the whole package. There's an old expression I think I maybe learned from Dan, when the first law of holes. When you find yourself in a hole, stop digging. And so I think we have to look at our emissions. The easy to abate emissions, it should be a slam dunk. And the harder ones, we need some technology development. But it's really, we need to do all of the above in switching to cleaner energy sources, in switching to better things to actually give us a more sustainable future. So it's just not one or a few things.
Okay, very good. So thanks, Eli. And Leon, welcome. Leon's our co-host. Welcome. What's your question for Steve?
Hi, Stephen. Thank you for coming on Climate Chat. Yeah, I have a question for you about the new Department of Energy report. It's called A Critical Review of Impacts of Greenhouse Gas Emissions on the US Climate, and it's written by, I think, only self-proclaimed climate skeptics in a way, right? Yeah, maybe you could, yeah, I don't know if you have your time to look at it yet, or what your thoughts are on that.
No, I haven't had time to look at it. I think there are two variants. One is people like Steve Kenan, who's very knowledgeable about climate. And his main thing is that the uncertainties are underestimated. And he's trying to say, we don't really know what's going to happen. I think that has been morphed by others into saying, this is not true. And there are others who just simply are saying, no, this is unlikely. And so there are these two types of climate. There's climate deniers, there are climate skeptics. The climate skeptic of the large uncertainty is the variety that I think Kenan is part of. When I discuss this with him, I say, okay, double the uncertainty. The mean's not going to change. And because of the risks, and especially the long tail risks, you still got to do something about it. He and I may differ on the urgency of what to do about it, but I think these long tail risks are very bothersome.
Yeah, uncertainty is not your friend. As you double the uncertainty, you double the worst case as well. But
yeah.
Anyway, thanks, Leon. Appreciate it. So we're going to go back to Stacy with one question from our YouTube audience. And Stacy,
Yes.
what do you have for us?
So do you know if the Department of Energy has or had projects to solve for the uncertainty of effects of aerosols on climate?
I don't know whether they do. When I was Secretary of Energy, certainly this was part of, the more you understand, the uncertainties may not go away. But to understand the uncertainties and how you deal with the uncertainties and what you do about it are really what it's about. Now, having said that, if you're of the persuasion that unless you're really sure, I don't want to deal with it. Imagine you go to your doctor and the doctor says, well, you're smoking. We know that's bad. You drink too much. We know that's bad for you. You're not exercising enough. And imagine you telling your doctor, well, unless you can guarantee, unless you assure me that if I continue all these bad habits, I'm going to get lung cancer or these things. I'm not going to do anything unless you tell me for sure it's going to happen. And the doctor is going to say, no, these are probabilities based on people can smoke to blue in the face and they don't seem to get heart disease or lung cancer. You don't have that discussion with your doctor. unless you can assure me that these things are going to happen, I'm going to continue what I'm doing. And so in people's own personal lives, you don't need certainty. You make educated guesses as to what, for your own health, what the best outcomes could be. And so I think this demanding certainty from science is not going to happen. Science, of course, by nature, you are never going to be 100 or even 99% sure things are going to happen.
But can you flip that? Because as Dan will often say, with what we know, there is so much uncertainty, but you wouldn't put your child on an airplane if we had these odds of the plane crashing, yet we continue to do the things or not study the things or whatever to get us to where we need to be so that our grandchildren have a shot at a livable planet.
This is maybe part of the human condition. I think never before has science told us what we're doing today will affect your children and grandchildren and great-grandchildren's lives. And so we're in new territory. That it's, it's generational risk. And usually what you're thinking about is your own immediate prosperity and the prosperity of your kids, maybe your grandkids, but that's as far as it goes. And certainly you're not going to be concerned about the kids and grandkids halfway around the world of people you'll never meet. Or, so this is a new thing to get your head wrapped around, that what people do all around the world is now going to affect us. The planet is small, the number of people is large, and the industrialization has made we have much more impact on our planet than we could have had 1,000 years ago. And so, but here's where we are, and we have to appreciate these risks, and the risks are large, and these. So how we deal with it is going to be a new societal thing. How to deal with risks. I long ago, when I was in Berkeley, heading Berkeley lab, I went and talked to a bunch of financiers in London. And they said, there was one person said afterwards, well, I kind of believe what you're saying has, a good chance of being correct. But I'm just me. I'm not going to be able to change the world. So my strategy is to make as much wealth as I can to pass on to my kids and grandkids so they can adapt.
That's
that works for him, maybe, but not for too many others.
The last comment left. When there is one tree left, how will you like to have your money printed on it?
Yeah. Anyway, Steve, I want to thank you so much for your time today, for your insights, both on science and on the political side. Very much appreciated. And I want to thank you so much for being on Climate Chat.
All right. Thank you, Dan. Thank you, Stacey.
And thanks to everyone.
Thank you, Stephen.
And I didn't say it before, but like and subscribe. And so we spread this information to as many people as possible. And we will see you next time. Bye-bye, everyone.
Okay. Bye.